All right, we're talking about guaranteeing storage performance in CloudStack. And as was just mentioned, I'm Mike Tutkowski. You can follow me on Twitter at MTUTKOWSKI if you'd like. I'm a CloudStack software engineer. Been doing CloudStack development for about 2.5 years now, as long as I've been at SolidFire. Been employed doing this for full-time for about 2.5 years. I've been on the project management committee, the PMC, for CloudStack over a year now, maybe 14, 15 months. And I guess as you'd expect, since I work at a data storage company, I'm primarily focused on CloudStack's storage component, specifically bringing quality of service into CloudStack. And as we'll kind of see as I walk through the slide deck, CloudStack wasn't initially designed with the concept of quality of service in mind. And it's a fairly large task to bring it across the board to the different features that are already in existence in CloudStack's storage area. So just a little bit about SolidFire so you can kind of see where I'm coming from. We're based in Boulder, Colorado in the US. Our system is a clustered scale-out SAN technology, basically industry standard hardware, Dell servers, with our storage operating system on top of them, clustering the storage nodes together into a single environment. And then from this, we allow you to carve out volumes and then export them to your hosts using either the iSCSI or the fiber channel protocols. And the big deal here, the big architectural point of the system is that you can take these volumes and you can make them as large or as small as you want. You can also guarantee performance independent of the size of the volumes. So you can have a large volume with a lot of performance, or a large volume with little performance, little volume with large performance. Those aspects are decoupled from each other, both the capacity and the performance. And we provide performance guarantees for each and every one of those volumes. So you won't have to worry about running in a cloud environment where you're sharing storage resources and typically you're susceptible to the noisy neighbor effect, which is when a tenant on your storage system becomes very active in an unexpected time and consumes a disproportionate number of resources from the storage system, thus depriving all of the other tenants a decent number of IOPS for their volumes. So they're actually impacted by something that another tenant is doing. So here, with the SolidFire system, you're able to isolate performance on a volume by volume basis and not have to worry about what your neighbors are doing on the system. Few more points. It's an all-flash array. The idea here is not so much for the raw performance, but rather for the performance predictability. We can layer a quality of service system on top of that that's extremely robust. And then through techniques like compression, deduplication, thin provisioning, this all brings the cost per gigabyte to be down in line with traditional disk-based systems. What's important to me specifically from this kind of a system is to have a really robust API, something that I can use from CloudStack to control every aspect of the system that I need to control. So just like any other third party who would need to interact with the SAN and control what it does, I, as a software developer on CloudStack, need to use the same API that our customers use. And we'll see here in a moment how we, through that API and then the ability to control performance, we can bring quality of service to CloudStack. All right, so I won't spend a whole lot of time on this. I think other presenters today have covered this well. But just to get everybody on the same page, terminology-wise, when we're talking about zones in CloudStack, it's basically a data center. It doesn't technically have to be that exact mapping, but usually a zone equaling a data center is a pretty good way to look at it. Then we get down to the pod, which is essentially your rack within the data center. And then finally, we're at the cluster level, which is what Tim just discussed in his presentation, where we're looking at hosts, either Zen Server, KVM, ESXi, Hyper-V. They're in this cluster area. And what they do in traditional primary storage in CloudStack is they either use their own local storage or they have shared storage that's only visible to other hosts in the same cluster. As of the 4.2 release, which is probably a couple years ago now, we were able to bring primary storage out to the zone level as well as what's also available, of course, still in the cluster level, but now it can be accessible at the zone level. It can be shared across clusters. And that may or may not be the idea that you have in mind. It's not like you're taking a single volume and sharing that volume across different clusters. What we're actually doing in our case here is providing access to a storage area network at the zone level and then dynamically creating a volume, giving it to one cluster, maybe creating a couple other volumes dynamically, giving those to another cluster. And you can continue to use the resources from that SAN at the zone level where the volumes that are created can be used in clusters, and then if they're data disks, they can be detached from VMs in a given cluster and attached to either VMs in the same cluster or in a VM in a different cluster, as long as that cluster is of the same type. But we'll get into this in a little bit more detail. I just kind of wanted to, at a high level, point that out. And then, as we just talked about a moment ago, secondary storage, of course, is at the zone level. That's where your ISOs, your backups, and your templates are stored before they get downloaded to primary storage and spun up into virtual machines. Okay, so traditionally, allocation of primary storage in CloudStack was a very static process. You, as an administrator, you'd have to go over to either your NFS system or your SAN. If it's a SAN, you'd go and create typically a large volume, maybe 2, 3, 4 terabytes. This is something that you would do outside of CloudStack. Once you had that volume created, you would then go over to another management system, in this case for your hypervisor, and let's say it's Zen Server. In that case, as Tim was talking about, you would create a storage repository with that volume that you just created. So now you've gone from the storage system to the hypervisor, and now you're finally able to come over to CloudStack and introduce that storage repository as primary storage. So you can see it's a very manually intensive process here. We'll get into it in a bit, how this has been automated. You can still do it this way, and in fact, this is still a common way for many people to do it, but it's very instructive to point out that this kind of a manually intensive process has been alleviated to a large extent through storage framework enhancements that have been done since the 4.2 release. But just traditionally, that's what you had to do. Finally, once you got that primary storage into CloudStack, this is when the administrator could go over to his or her service offerings and create compute offerings and disk offerings. So for those who aren't familiar with those terms, a compute offering is a template for your virtual machine. It's what specifies how many virtual CPUs you want, how much memory, do you want to use shared or local storage for your data, your root disk, those kind of characteristics. Oh, and by the way, when I say root disk, sometimes I get the question, is that a boot disk, a bootable disk? Typically in CloudStack, we tend to use the word root disk, but yeah, boot disk or bootable disk, those are all just being used synonymously here. So compute offerings, those are your templates for your virtual machines. Disk offerings are your templates for volumes that users can create and then attach those volumes to virtual machines. So you could think of those as like extra data disks. Maybe you have SQL Server running on your OS, and it wants to store its logs in one data volume, and it wants to store its actual data in another data volume. So you would use, as a CloudStack user, you would go to a catalog of disk offerings that your administrator had created, and you would select the one that meets your needs. In this case, it could be a certain size and or performance characteristics. Then you would go and create that volume and attach it to your virtual machine, and away you go. So keeping this in mind, this is the traditional, more static approach. We'll see how this has been automated. All right, so on the left, this is the approach that I was just referring to. This is where you take a large volume, you make a storage repository, you bring it in as primary storage. Those things are done manually. Then when you spin up your virtual machines and you create data disks for them, your root and your data disks, they have to go somewhere. And this primary storage is essentially a candidate amongst all of your primary storages to store those virtual disks. So to store those root disks and those data disks. So what we're seeing here is your virtual disks, there are many of them on a back-end volume. Now this poses a problem from a quality of service standpoint. And this is the way that CloudStack was initially designed. And it was done for practical reasons. There were LUN limitations and things like that in place when CloudStack was being engineered, and this was a straightforward enough way to design it originally. But it does have limitations from a quality of service standpoint. Even if your back-end volume, let's say it's a SolidFire volume and you've got guaranteed performance, if you're running multiple virtual disks on that back-end volume, those are like mini tenants, and they can compete with each other for the guaranteed IOPS of the back-end volume. So just because your back-end volume has guaranteed performance, that doesn't necessarily equate to any individual virtual disk that's running on that back-end volume. So what we really want in an ideal world is this picture on the right-hand side. This is where you have your own back-end volume, your own logical unit per virtual disk. So there's a one-to-one mapping there. Back-end volume, ideally with guaranteed performance, to a single virtual disk. And that way you know what that back-end performance of the disk is what the virtual disk will expect to receive. Now this is not easily facilitated in the traditional CloudStack storage framework. You would have to be able to dynamically create and delete volumes on the back end, storage repositories. If it's ESX, it would be data stores, but the same problem exists for all of these different scenarios. You need some way to be able to dynamically create and delete these kind of objects, volumes and storage repositories, data stores. And so this really wasn't possible until the 4.2 release of CloudStack, where the storage framework was completely revamped to include the concept of storage plugins. So prior to the 4.2 release, vendors like SolidFire, if you were iSCSI or fiber channel based, you just integrated as generic iSCSI or fiber channel storage. There was no support for any particular feature sets that you might have on your system, like snapshots or quality of service or anything like that. You were just generic iSCSI or fiber channel. As of the 4.2 release, it really opened up a wealth of opportunities in what storage vendors could do in CloudStack. And from my perspective at SolidFire, the big opportunity here was around quality of service. I could write a plugin, and it actually wasn't so straightforward at the time as writing a plugin. I had to participate in the process of revamping the storage framework to enable quality of service. But now that that storage framework has been augmented in this way, it's simple enough that you can write a storage plugin to have CloudStack let you know when volumes need to be created, when they need to be destroyed. Let Zen Server know when it needs to create a storage repository on a brand new volume. Let Zen server know to delete that storage repository. I don't need it anymore. So all of these things have been drastically enhanced as of the 4.2 release. And it wasn't really all completed in 4.2. This is a fairly extensive number of changes we're talking about here. Probably, now we're looking at the 4.5 release. We were talking about that this morning. Most of the large functionality is implemented as of 4.5 to support the use cases that most people have, but there's still work to be done around snapshots and other areas, which we'll get into at the very end of the presentation. So just kind of at a high level here, the left side, that's the traditional approach, where a single backend volume hosts multiple virtual disks, not ideal from a quality of service standpoint. The right-hand side, everything is dynamically provisioned. You have a backend volume per virtual disk. If your backend volume supports quality of service, therefore your virtual disk has its guarantees, your performance guarantees. So, how do we actually add primary storage to CloudStack that's based on a plugin? In this case, I'm going to, of course, use the SolidFire plugin as an example, but the idea applies in general to storage plugins, and then, of course, some of the parameters would be tweaked. We'll get to that at the bottom, depending on your vendor. At the very top, we see the scope option. So in this case, my storage plugin is going to operate at the zone level. I'm going to take advantage of that zone level primary storage. I'm also going to support pretty much any hypervisor. Right now, technically, it's Zen Server, ESXi, and KVM. But you would select the any hypervisor option. You pick your zone, you give your primary storage a name. The protocol, there's a new option called custom. If you select the custom option, you will be given a bunch of additional fields below it. One of them is this provider. Now it's populated, this combo box is populated automatically by all of the storage plugins that are installed in your CloudStack installation. So the SolidFire plugin, it's part of the CloudStack code base, so you would just see this as an option by default. I've gone ahead and selected it in the list. This is known as managed storage. Managed because it will automatically create and delete volumes as needed versus unmanaged would be the traditional approach where the administrator is responsible for going ahead and pre-allocating that volume, pre-creating the storage repository. So that's not what we're talking about here. We're talking about this managed automated framework. Check the box. Now the capacity bytes, this is kind of a funny field because usually you'd expect things to be in gigabytes. For whatever reason, this particular field has always been in bytes in CloudStack, and the API expects it in bytes. So you have this ginormous number. This is actually, what's important here is to realize that this number is not the size of an individual volume. This is telling CloudStack how many bytes from the SolidFire SAN I will allow it to use for when it needs to create volumes. And below that is how many IOPS, how many guaranteed IOPS. So, for example, maybe you create 100 volumes dynamically. Maybe on your 101 volume, you exceed the capacity bytes or the IOPS. Well, that's when CloudStack will cut you off and say that you don't have the ability to create that particular resource. So this is your way of taking that back-end resource and telling CloudStack how much of it can actually use. So again, it's not the size of an individual volume. This is two petabytes here. This is how many bytes from the back-end resource, the SAN in this case, that CloudStack is able to utilize. And then the unique part here for the SolidFire plugin is specifying how many IOPS from the SAN can be delved out to volumes as you create them. The URL field, that's very vendor specific. It's typically a collection of key value pairs that are semicolon delimited. They'll say things like the IP address of the management network, the IP address of the storage network, what's the cluster admin username, what's its password, all of those kind of tidbits of information that you would need to provide to CloudStack to enable it to interact with that back-end resource. It would use, for example, this MVIP, this management virtual IP address. It would use that IP address when the time came to talk to the back-end SAN and have it create a volume dynamically. So we've got all of this filled out. The last piece of information is the storage tags field. Now, traditionally, this is the 4.5 GUI that we're looking at. Traditionally, this has been just a comma-separated list of descriptors. So this is your opportunity to describe this primary storage, and we'll see how these descriptors are used in a bit. Previous to the 4.5 release, you had to type in the descriptor. If you wanted multiple descriptors, you had to separate them with a comma. It was kind of like a little bit of a nightmare as far as like filling things in. I had a university student over the summer of 2014 who was working on Google Summer of Code, so I was his mentor for that summer. And one of the projects he worked on for me was to add a JavaScript control which made it much more easy to enter in these kinds of description fields. So you can type in here SolidFire _1, you can hit the space button, and now it shows up in kind of its own little object that you can hit the X button to remove it, or you can go and type a new descriptor, and it's an easier way of interacting with these storage tags to create and delete them, rather than having to type things all out, separate them by commas, and worry about things like that. So anyways, we've got this all filled in. Now's our opportunity. We hit the OK button. We actually send this command to CloudStack to create this primary storage, and this is what we see. So you can't actually see the bottom left, but we're in the infrastructure tab, and we've actually gone to primary storage. This is our listing of my primary storages, and the one I've circled is the primary storage that we just added. So it's got a few pieces of information, not all of the details. You'd actually have to click on the row if you wanted to go in and get all the details. But just at a high level, it tells us at least one important piece of information. This primary storage is at the zone level. So it's not host or cluster level. Host would be local storage. It's not local or cluster storage, it's zone-wide storage. The other piece of information here, which it's not really visible in this particular screenshot, but we just kind of covered it a moment ago, it's primary storage that's based on a SAN. It's not primary storage that's based on a pre-existing volume. So it's just based on a SAN, and when we need to use resources on that SAN, that's when we'll dynamically go and create that volume, use that volume, delete that volume later, free up those resources. So let's move along and actually make use of that primary storage. So I'm still an administrator. I'm going in, I want to create a disk offering. We could do the same thing for compute offerings, but let's just try disk offerings. I'm in the Service Offerings tab. That would be way at the bottom left. You can't actually see it. It's been cut off in the screenshot. And then in the Select Offering combo box, kind of in the middle, I've selected Disk Offering. And then in the upper right, we want to go ahead and add a disk offering. So we'll click on that button. All right, only one dialog comes up here. I know there's a couple of them being shown. They're really just because I want to draw attention to a difference in options that you can select. So this dialog comes up. You fill it out with the normal information that you would for a disk offering, the name, the description. In this case, I actually even specified, if you look at the one on the left, I actually specified how many IOPS to expect when you execute this disk offering. So that volume that you create will have that minimum number of IOPS. This is shared storage. There are a few fields that we can skip, like provisioning type. You have to remember that CloudStack was actually designed to interact with a lot of different storage. providers, and for some storage providers, they may have fully provisioned versus thinly provisioned options. In my case, provisioning type, it doesn't really matter what you select there. It's always going to be thinly provisioned, the metadata, the actual data, so I just tend to skip that field. The next one is the disk size. In this case, I've actually specified 100 gigabytes. If you look at the checkbox above and check that checkbox, that would actually be where the administrator does not want to specify the size of the volume. He or she wants to pass that option on to the end user who actually wants to create a volume based on this disk offering. So typically what happens is the administrator is going to be the one who puts in that volume size, and then the user would select which size they want from a catalog. Sometimes, maybe more so in a private cloud offering, sometimes the administrator will just check the box and say, I'm going to let my end user pick the size of the volume. If we look at the options below, we have a similar concept for storage quality of service. So the QoS type, you have a few options. You have no quality of service, which would just be pretty much business as usual. You have hypervisor quality of service, which is actually rate limiting for the KVM hypervisor. And then you have storage quality of service, which is what I selected. In this case, I've actually input 104, these are all 4K based IOPS sizes. So the min IOPS, I've put in 1,000, the max at 2,000. But if I wanted to, as an administrator, again, maybe more in a private cloud environment, I could check that box, custom IOPS, and pass that choice on to my end user. And you can mix and match these. You could specify the volume size, but let the user pick the performance. Or maybe you pick the size and the performance, or whatever. There's 4 different permutations there. Below that, once you've selected quality of service for your end user, or you've allowed the end user to pick it, there's this concept of Hypervisor Snapshot Reserve. I don't want to get into that right now. I have a slide at the very end, but let's at least try to remember the term Hypervisor Snapshot Reserve, and that it's part of a disk offering and also a compute offering. The write cache, inapplicable for my particular type of primary storage, so I just skip it. Now, for those who aren't familiar with storage tagging, this is kind of where this will maybe come together. When a user actually executes this disk offering to create a volume based on this template, we want to know what storage it's eligible to be placed on. And from the storage tags here, I've said that this particular disk offering, it has to go on primary storage that describes itself as SolidFire _1. Now right now in my particular little cloud here, I only have one primary storage that describes itself that way, so it's a pretty easy choice for CloudStack. But that's the way that you tie in your compute offerings or your disk offerings. The compute offering would be relative to the boot disk. But the compute offering and the disk offering, that's how they find a home for their disks, by specifying the characteristics of the primary storage that they require. So in this case, I only specified one thing. If I specified 2 things, my primary storage would have to satisfy both of those things. And same thing, it's basically an and kind of a situation here. So in this case, I just have one tag. All my primary storage has to do is say that it supports SolidFire _1, and the primary storage that we just looked at does. So we'll hit the OK button. Now we've got our disk offering, and let's say I'm a regular user. I've logged into CloudStack. I want to create a data disk. I want to have an extra data disk that I want to attach to one of my virtual machines. So what I do is I click on the Storage tab, and then in the upper right, I'll go ahead and click on the Add button, and that'll take me into the next dialog. And again, there's going to be 2 instances of it here, but in reality, you're just brought to one dialog, and then based on a selection that you make, you might have more options. So on the left, let's take a look. You just fill in the name, you fill in the availability zone where you want the volume to reside, And then you pick your disk offering. In this case, what I've circled is the disk offering that we just created a slide back. Now, there were two of them. There was the one where the admin specified the quality of service, and there was the one where the end user could pick it. So if we selected the one where the admin picked it, we're basically done at this point. We can hit the OK button. If we selected the one that had customizable IOPS, then CloudStack would know that and provide a couple extra fields, the minimum and the maximum IOPS, and then you could fill those in yourself. So the administrator, in this case, happened to pick 1,000 min and 2,000 max. In the right-hand side, we're just demonstrating that this particular user decided he wanted more performance, so he put 2,000 minimum IOPS and 3,000 maximum IOPS. So once you've got one of these filled out, you hit the OK button, and we'll have our volume listed in the CloudStack database's volumes table at this point. So there is, I guess, the important part to note here is that by hitting the OK button there and creating the volume, you really just added an entry to the volumes table in the cloud database. There is no new volume on the SolidFire SAN at this point. Therefore, there's no new storage repository. You have to wait until the end user decides to attach this volume to a VM for the first time. Because what will come into play there is the hypervisor that's in use, depending on what hypervisor type that particular VM is running on. So, and I'll actually show you how this looks on all three of the hypervisor types that I support. But from CloudStack's point of view, the user goes to the storage tab, drills down into the details of his volume. There's a circled icon there, that's the attach button. He clicks that. He gets this dialog, attach disk, which I've represented in the right-hand side. You just pick the virtual machine. You pick the virtual machine from the list and hit the OK button. Now this is when kind of all of the orchestration magic comes into play. This is when CloudStack looks at the volume that you want to attach to the VM. It takes a look at the disk offering it came from. It looks at its storage tags field, sees what its requirements are. In this case, SolidFire _1 is what it requires. CloudStack goes through its list of primary storages that are in the zone for that volume, and it'll find, hopefully, it'll find primary storage that matches. In our case, it will, because we know we've created primary storage that describes itself as SolidFire _1. Once CloudStack finds the primary storage that it wants to use, and if there's multiple options, CloudStack can make that choice. Once it finds that primary storage, it'll look up the plugin object that supports that primary storage. And it'll start invoking functionality on that plugin, like, hey plugin, go create a volume for me. In my case, the plugin interprets that as, go take the size of the volume, the quality of service. You also told me what the address of the SAN was as an administrator. Go talk to the SAN and create that volume with the appropriate size and performance characteristics. Make sure it's in a SolidFire account that maps to this CloudStack account, so you have this concept of multi-tenancy, not just in CloudStack, but also on the SolidFire system. And once you've got that done, go and report the IQN, the iSCSI qualified name, back to CloudStack. CloudStack will then orchestrate the rest of this. That could be creating a storage repository to consume that volume on Zen Server, or creating a data store on ESXi to consume that volume, whatever the appropriate requirements are there. Once your hypervisor data structure, like a storage repository, is created, then you can create a new virtual disk image that represents that particular volume and attach that to your virtual machine. And once you've got that, maybe take a look on the next slide here. Oh, actually, I probably should have been describing this visually the way I was going. So what we can see here is, on the SolidFire SAN, we have a new volume. It has the right performance characteristics. I guess I just covered that a second ago. Then we get over to the hypervisor. We can see in the bottom left, we've created a new storage repository which consumed that new volume that was on the previous slide. Then there's actually, you can't actually see this on this slide, but if you were to go and look at the storage tab in XenCenter, you could see that there's a single virtual disk image in that storage repository. So it's by itself in that storage repository. And then if you looked at the actual virtual machine, and I've done an fdisk-L, you can see at the top, yes, it has its root disk. The more interesting thing that we want to see here is that second device, roughly 100 gigabytes. And that is our virtual disk that's on its own SolidFire volume with, of course, not only its own size, but also its own performance characteristics. And you could continue to create data disks and attach them to the same VM or different VMs. Each one can be its own size with different performance characteristics. No one else on the system is capable of taking the minimum IOPS away from your volumes. So you eliminate noisy neighbors, which are typically prevalent in cloud environments. Let's see in general what happens on ESXi. So instead of a storage repository, we have a data store. Same idea, though. This is a clustered file system that the hypervisor has applied to the backend volume. And then we can see kind of in the upper right, there's another arrow pointing to a VMDK file, probably fairly difficult to read on that image. That is our virtual disk, which will be attached to the virtual machine. And then at the bottom right, this is very much what we just saw on the previous slide. Same idea in VMware. We're going to see, of course, if I run fdisk-L, not only will we see our root disk, but below that we'll see our new device, which has its own guaranteed quality of service characteristics. In this case, it's 100 gigabyte size as well, same as the previous slide. And then the next hypervisor to cover is KVM. KVM is a little bit different. So what will happen here, KVM will do a login to the target. It will discover the volume that we just created. KVM does not apply a clustered file system to that backend volume. It just takes that whole volume and it passes it into the virtual machine. So what we'll see here is on the left-hand side, that's my hypervisor fdisk-L readout. And on the right-hand side, that's from my virtual machine running within that hypervisor. And they're going to be very similar. The part that's the most interesting to note is where the arrows end up. And we can see that that is, again, the same as on the previous two slides. That's our new device with its own guaranteed performance. So this covers the 3 hypervisors that I support. Let's take a look and see what this looks like from CloudStack's point of view. Now, we actually only did create one volume. In this slide, I'm pretending like we went back and created another one on a different hypervisor and then another one on the third hypervisor. So I've repeated the create volume step 3 times and on different hypervisor types each time. And the way I made that happen was I had a virtual machine running on XenServer, one running on ESXi, and one running on KVM. I created 3 volumes, and then I attached one to one VM, one to the other, one to the other. So in the end, what we'll see here from CloudStack's point of view is this just looks like a regular CloudStack volume. The really interesting part to note here is it's all backed by the same primary storage, which exists at the zone level. And so if you see within the circled area, the hypervisor is different for those 3 volumes, but all 3 of those volumes are on the SolidFire SAN, and they're within CloudStack represented by the same primary storage. Now, Tim kind of alluded to something like this in his presentation about conversions and things like that. You are restricted to, once you've attached your volume to a VM for the first time, it's fixed on that particular hypervisor type. So if you had a data disk attached to a virtual machine that was running on ESX, you can detach it, attach it to other virtual machines in the same cluster, outside of that cluster, as long as they're ESX backed VMs. Same thing for XenServer and KVM. So the first type of, so the VM that it's, whatever hypervisor type it's running on, when you attach your volume to that VM for the first time, at that point, that CloudStack volume is that kind of a volume. It's associated with that kind of a hypervisor. So just kind of figured I'd point that out. But they are all residing on the same back-end primary storage. You do have mobility of your data. If you have multiple ESX clusters and you want to take that data volume and detach it from one VM and attach it to another VM running in a different ESX cluster, you can do that. You're not limited to that cluster anymore. All right, so wrapping it up here, I just wanted to point out a couple additional features, some of which are still in development. So there's the concept of a hypervisor snapshot and a volume snapshot in CloudStack. The hypervisor snapshot is pretty much as you'd expect. It's snapshots supported at the hypervisor layer. So what this typically means is in, for example, Zen Server, you have your storage repository. Within that, you have your virtual disk image, and that's where your writes are going to. Let's say that virtual disk image is for a data disk. Your writes are going into that VDI, that virtual disk image. If you take a hypervisor snapshot, you will actually create another VDI which collects the newer writes. So the old VDI will stay the same way it was when you took the snapshot, and then the new VDI will collect the new writes. And so that way, if you ever want to, you can revert back to where you were when you took the snapshot. So there's kind of this parent-child relationship between virtual disk images within a storage repository. And kind of as I noted here, VMware has the same idea with VMDK files. They're implemented similarly, not exactly the same. But I do support this kind of snapshot with the plugin. So one question I do normally get is, like, how does this work when you have a single virtual disk image in your Zen Server repository? You need that single virtual disk image for quality of service. It has to be the only guy in that storage repository. Can I still take hypervisor snapshots? And yes, you can. Those, even though you would actually end up with multiple virtual disk images in the same storage repository, they represent the same virtual disk, and they're backed by the same SolidFire volume. Therefore, you do get those same performance guarantees. And the way you control this is through that property that I kind of glossed over, the hypervisor snapshot reserve. So when you create a storage repository, I'm sorry, someone just told me how much time I have. I didn't see. How much time was that again? 1 minute. Oh, I better speed it up. All right, so you can control this through hypervisor snapshot reserve. This is your ability to make the storage repository larger than that single virtual disk image. So if you needed that virtual disk image to be 100 gigabytes, you can make your back-end storage repository, let's say, whatever, larger than that. And that way you can take hypervisor snapshots and they can all fit within that same storage repository. Same concept applies on ESXi. I won't cover a whole lot more of the details on that due to time, but I guess the gist is that hypervisor snapshots are supported. And then volume snapshots are what a lot of people call backups. This is, you want to take a volume snapshot. It's a copy of your virtual disk image that's placed on secondary storage. And one of the things I've been working on, especially with Zen Server and ESX, is to take snapshotting off of secondary storage and be able to put that on primary storage. There are a lot of, and I'll be done in 2 seconds, sorry about the time. There are a lot of advantages to being able to keep your snapshots on primary storage versus secondary. You can have very fast snapshots utilized from the SAN. On the SolidFire system, the data is all compressed and deduplicated, so not only is it a very fast snapshot, but it's very space efficient. And so this is one of the areas that I'm really turning my focus to now within CloudStack is snapshots on primary storage. And I think that covers everything. I don't know if I have any time for questions because I don't want to hold up the conference, but definitely feel free to stop by and ask me any questions. I'll be over at the SolidFire booth in between during breaks. So thank you.